Yeah. We can start. Today we'll talk about jobs, something called jobs, cron jobs in KTS. You know what is cron jobs already? Schedule anything, it will run it for you on a specific time. So same thing we'll do in Kubernetes. That's it. Like usually, what we have seen as of now with deployments or with pods, replica set, replica controller, daemon set, stateful set. These are all we have used. To create the pods, right? These pods will run permanently until we delete it or someone delete it. So these our applications usually will run. Let's say I have a scenario now. I have a script or some command, whatever it is. I want to run. This will get executed maybe in 5 minutes or 10 minutes. You know, I want to run something temporarily. So with pod, let's say I'll create a pod. I want to run in Kubernetes. Of course, the same thing can be done with Jenkins as well. Just create a freestyle job or pipeline job, run your task. Once your task is done, it's fine, normal. But let's say they're not using that. They have only Kubernetes and they want to run the script in Kubernetes because of some reason. It can be like, they want to access Kubernetes resources so that they're running inside the Kubernetes cluster, like it's anything. So at the time, yeah, we can run a pod. It's fine, completely fine. But the pod will be present until we delete it manually. Correct? That's what usually happens. But I don't want that again. If the job, whatever my script which I want to run, whatever my task, if that is done, I want it to stop it. Terminate it. Don't run it because it's waste of resources. Like I'm wasting CPU, I'm wasting memory by running it unnecessarily, even though there is nothing running inside it. So to have this temporary, pod running, until our task is done. Let's say whatever it, or command, task, script, anything it can be. We have something called a job. Let's start with the jobs. So create a job, tell your task, it will do that, and once it is done, it will close it. So today we'll see that how to create a job and how to run it like that. Let's see. First, let's kubectl get job. See, there are no jobs. We have namespaces, right? Let's see. No, we haven't created any job. See, let's create one. Simple, very simple. You know the ML syntax already. Let's just follow that. What is the first one? API version. Obviously, you know that. For a job, what is the version? Batch slash v1 and kind job, obviously. Metadata, so you know the same. A test job. If you want to run, wait. Metadata name I have to give, right? I'm simply giving. And if you want to run the same job in some namespace, you can do it like this. But yeah, I don't want it. It's default is fine for me for this. Now this is common. Next is spec. So in the spec, we create a template, pod template. You know this already. Why the pod template? We are creating a pod only, but a temporary pod until our task is done. So that's why the pod template is fine. Next, another template right below the metadata, starting here. If you observe spec, what is this spec for? Containers. We have to create a container, right, to run our task. It's spelling wrong. Maybe test job, something, anything, whatever it is. Blah, 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 something. Any task, let's say I want to run some echo print statement, echo hello world, generally in Linux, usually you see that CentOS 7, I use it. Anything, does not matter. Ubuntu 22, let's say Ubuntu 22, we have already image. Ubuntu 22.04. Any task, you want to run some Python script, you want to run Java or shell script, you can use this. Now here you have to define what is the command, sorry, command. My command, my task is like just to print something. Maybe I'll print, hey, this is Kubernetes or something like that. That's it. Maybe echo what to print. That's it. Just want to print it. I don't have any, specific task. You can run same thing. We can add one more thing called restart policy. On we can have never. It means never restart this pod. Okay, good. So or this never can be changed to on failure. It means if the job is failed for some reason, you'll try to restart the pod. So this is the ML. That's it. This you know it. Kind job pod template because we are creating a pod, a temporary one. Once the task is done, it will be terminated. Spec. These are container which I want to use on a container name, image name. You know this already. And this is the command I want to run. If you have any script, let's say execute a script here. Write the script execution command here. That's all. Go valid, copy paste. It will be yes. Job.yml. Let's simply paste it. Now let's try to run. kubectl apply -yes job. It's created. Now what is the command we see? kubectl get jobs. If you observe here, test job, okay. Completions one by one. He gave the task, it's already finished. How much time it took? 3 seconds duration. This is normal, I mean, when you created the pod. But the task is done already. How do you know? Maybe describe it. Sorry, kubectl describe job / test job. If you observe here, I mean, these are all normal pod things. Created a pod, job completed. The task is done. Still, of course, we didn't see it. How do you see? Try logs maybe. Logs will show you. See, this is a sample job in KTS. I think that is what we have added. Let's see the print statement. The task is done. The print statement is over. There is nothing. So it's finished. The job is finished. Sorry. See, test job is this is the pod is created. Test job something. But if you see running 0 by ready 0 by 1, it's not running any pod. Why? Because the task is completed. Then the pod is terminated. I mean whatever the container inside. That's how to create a job. Let's see this one. Kubectl get job completions. It is showing one by one. What does it mean one by one? Is it pods? No. It's like how many times you want to execute this thing. Let's say I have a script or this command. Let's imagine this command. I want to execute this maybe 4 times or 5 times or 10 times. You have to give that number here in the job configuration so that it will run that many times, and the completions will show you that many times. Let's add that maybe in this. Yeah, sorry. In the spec we can add. completions 4. Let's say 5. It means the same command, whatever we gave or whatever we give here, this will get executed 5 times. And output obviously will be shown for 5 times. If you want to run this kind of scenario, you can add this simply completions. kubectl apply -f job. Wait. Something is wrong and someone came. It says field is immutable. COMPLETIONS. Yes. Number 5. Did I give wrong? No, that's correct. Let's see. Invalid spec completion invalid value 5. Field is immutable. Field cannot be changed. Oh wait, I cannot. Its job is already running. I can't update the job. So let's delete the job. Job deleted. Now apply again. See, it's created. Because once the job is created, we cannot change it. Because the job is finished already. What is there to change? That's why. If you observe, see, 5 times. Because we are told, hey, run this job 5 times. That's what we told in the configuration. And it's fine to run 5 by 5 completed. How do you check, you know, check the logs of the job? Found 5 pods using, this is sample job in KTS. So what it does, now let's see. See, what happened here is you told, hey, run this 5 times. And what, this job did is it created 5 pods for you. Run the task 5 times, one by one. 5 pods for you. Any number if it, let's say 100 you give, what happens is it will create 100 pods for you. Run the task one time in each and every pod. That's what it will happen. That's what it's gonna happen. Is it clear? There will be scenarios like this, to run multiple jobs multiple times. Depends on their configuration. Depends on their what they are doing. But generally don't. So it's fine. So you can give like this. Where is this? So how many times you want to run a job? So it will create that many number of pods, and it will try to execute the task in each and every pod. Now let's add one more thing. There is one more thing called parallelism. Jobs 2 are fine. I mean, why to create 5 containers? This 2 is fine. Something called parallelism. 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 Let's keep it 4. This one for this example. So now, what is this parallelism then? Okay, completions you told, okay, it will run that many times, it will create that many pods and run the task that many times. What is parallelism mean? This completions, what it will do is generally, it will execute the pods one after the other. One after the other, it will create first pod, execute the task, second pod, it will create second, execute the task, create third, execute it. Like this, it will do it. Let's say we have 100, it will take too much time, right? This parallelism helps us in running the pods simultaneously. Parallelly, with the name you can identify. Parallelly, you can run it. It means it will create 4 pods. Overall, it will run 4 times. It means create 4 pods. 2 means 2 at a time. Parallel, 2 at a time. If you let's say give number 2 here and parallelism 2, it will run job 2 times at the same time, parallelly, not one after the other. You got what I'm saying? So let's say you kept 50 here, completion 50 times you want to run. Parallelism you kept some 10, it will run 10 at a time. The task 10 times means it will create 10 pods at a time, run the script, whatever command we gave in those 10 containers at the same time, parallelly, so that we can reduce the time also right here without wasting anything. Got it right? Is it clear? Is it okay within parallelism? Did you figure it out? I mean, is it clear?
Yes.
So yeah. So now what happens? Completion. I told that okay, it run the job two times, and parallelism two I gave me it will run at the same time. At the same time, without not have one by one. If CTL apply created by the time we executed the command, it might have been created, but it for sure it will work. Two by two. It's already finished. If you observe, same seconds. If you observe here, this is the old one, right? Say, observe the age. First, it will create this one. Once it's finished, because how do I know it's finished? Because it's completed, and of course, see the timing here, duration. Just taking 3 seconds to execute the task, whatever we gave. So 24 plus 3, 27, the second one plus 30, see 36, 33, 36. See, within 3 seconds gap, it is creating one by one. Generally, without parallelism. Observe here, the parallelism, both age is same because it's created parallelly at the same time. That's how. That's how we can able to use the parallelism to run the task parallel. Let's delete minus f again. Job Jobs are deleted. kubectl get job. Nothing obviously. That's about the jobs. So far, if you observe, I'm creating the jobs. Okay, it's working fine. After the completion, I'm again deleting manually. Correct? That's what I did so far. I'm deleting it manually so that whatever the completed parts will be gone. By default, they are not going. If the job is completed, they should go. I mean, they should delete automatically, but they are not going. Correct? That's what we are doing manually. We can add some conditions for that as well. You know what we can do is TTL seconds. TTL means time to live. How much time the job should be present after it finishes. So we can define anything. Let's say 5 minutes, seconds. We have to define in seconds actually. So anything, 10 seconds, 20, 100, 1000, any seconds, it will keep the job at that until that point of time, and it will delete it. Maybe 20 seconds for me. So after the job is finished, it should delete within 20 seconds. After 20 seconds, I mean. So it means job will run for 3 seconds, and after that, after 20 seconds, it will delete. It means total 23 seconds. Let's try this. kubectl apply hyphen yeah, job created kubectl get job 4 seconds. Let's watch it. Let's see. Of course, 2 by 2 already finished. That's fine. So we have to wait for 23 seconds here. Let's see if it is deletes or not. Sorry. See, gone. You can see it. kubectl get jobs. Come on, where is the comment? See, there is nothing. Get pods. Nothing. It's already deleted. We told that, hey, after some time, delete it. I don't want it. We really don't want it because once the task is completed, why would we need the jobs to be displayed? It's unnecessary, right? Just unnecessary. That's why we delete it. That's about a job. You want to create anything, a sample, anything, anything which runs temporarily, you can use go for a job, not for a pod. Pod we have to delete once the script is finished. The pod will be running always until we delete it manually, which will be consuming the resources. It's a time waste for us. I mean, resource also we are wasting. Simply go for a job. Once your task is finished, it will automatically delete the container within the pod. So all good. And we can add few more things like uh, like called completions, how many you want to run, parallelism, after how many seconds it should delete automatically. So all these things. So this is called a job, which you will be using for a temporary use case. Got it? Now there is one more thing called cron job. Same thing, job runs and deletes. It's a one-time task. When I created a job, let's take this example. I told run 2 times parallelly and delete after 20 seconds. It will delete. This is one time thing. Let's say I have a scenario that now I want to run job multiple times a day. At the time, you simply use cron job with the cron expression. It will create at that time. As simple as that. Just like Linux cron job. Here also we give cron expression minutes, hours, days, months like this. Based on that, it will create a job. Whatever the we give execution here, it will do it. And once it is done, it will automatically delete based on this. And again, based on a cron expression, it will create, it will delete. Same thing. I mean, cron job is nothing but a job which is running, uh, multiple times based on our intervals, our requirements. Don't ask what is cron job. I already told you. You know it already. Okay. So now all I have to do is change this kind to cron job, and remaining all are fine. Only thing, what is required for cron job? Schedule. When to run? For now, we'll try every 5 minutes. 5 minutes we can wait, maybe 2 minutes or 1 minute also, because our job just takes 20 seconds to run and delete. I think this should be fine. Minutes, hours, days, month, week. 5. Let's save it. Wait. Template to change to C job. kubectl apply hyphen f C job. Oh, there is something wrong. Cannot be. Oh, wait. You know what is wrong here is, if it is a normal job, we can use this. But if it is a cron job, I mean, task can be same, but parallelism completions do not work. Sorry, my bad. So it won't work. And one thing is the syntax will be changing a little bit. So schedule is fine. Template is good. Instead of template, we have job template. Job template. No need to have this part specification now. Where is it? SPEC. And here there will be another template. Everything will be inside. Restart policy will exist. No worries. It should be. Oh my god. It should be a little more inside. Yeah. So now observe. Earlier we have similar kind of thing. This is fine. We have a spec. Inside spec we have template. I mean, with our features like completions or parallelism, and we have normal pod template. So where we will be defining our things. But of course, pod template exists now. It won't change anywhere, as I told you. Only the above spec change. So in above spec, it has cron job does not support parallelism, all these things. You have to run the job based on your interval. That's it. And there will be a job template. Inside that there will be spec, again template, where we have container spec. This is about CronJob. It does not support parallelism. My bad, I missed it. Let's try this. Create it. Click CronJob. It's running. So every 1 minute, we have to wait for a minute. Let's wait. Just I think few seconds. We can wait. Mm-hmm. Mm-hmm. Okay, it's done. Let's see. Come on. Is it stuck already? It got stuck. Yes, a minute. Excellent. kubectl get pods. See, they're finished. The cron job is they're created and they're finished. Get cron job. See, it will automatically create it. Based on our restart policy, it will automatically delete. That's what we do. So you got it. What is cron job? What is job? I mean, what is cron job? Is it clear?
Yes.
Sorry. Any doubts so far?
No.
I mean, it's straightforward, I know, but with a little extra things like completions, parallelism. So try using that. Then it's one time thing. I mean, once you practice it, you will easily figure it out. There is nothing that much complicated.
So
So
in CronJob, we don't need to mention TTL, right? It will automatically delete the pod.
it will automatically delete, but it will take some time because we gave very less time because what is that? Oh, sorry, 1 minute we gave. Sorry, yeah, 1 minute. So every minute it has to run. So our it will wait for 60 minutes. Sorry, 60 seconds. And what is our task completion time? 3 seconds. 60 seconds it will wait and it will delete. But now another pod is running already. So there is no time to delete. But usually it will delete if you give some more time. I mean, just for a testing, I just gave like that. But usually we'll have more time. So once you have more time, the TTL will be less obviously, right? What happens here? There will be time to delete. So that's what I mean. Is it clear? Now what I was saying, I'm just creating a sample pod, sample Ubuntu pod. Don't worry, because yesterday we tried, right? At least I'm trying today if it is working or not. Because the next topic which we'll be discussing is about communication. That's why I just wanted to figure it out. Hmm. Mhm. Super. Instead of let me just Let me write. Uh, See, it's how much time it's taking. Let me open a new window. Meanwhile, let it finish. Mm-hmm. Let me write a Docker file, a sample Docker file. Now, why I'm trying all these things is to show you the communication. I mean, because kernel does not exist in the running container, so installing there will be difficult. The different packages, but here it's easy, right? That's why. Mm, this website I'm installing all these things. Sorry. Let me build image. Oh wait, Docker is not available. Container D. Let me write the command first. Build a kit we don't have. Yeah, that's instead of all these things. Let's wait. Let's not waste time here. Let's tell delete. Let's this doesn't want something. I want the reason. Oh, okay, it's still terminating. That's fine. Let me write create one more pod. I'll tell you why I'm doing all these things. Don't worry. It's done. Let me go inside a pod. Kernel not found SDK update. What VKML? control not be deleted. Oh, it's running. What the hell? Let it delete. This also didn't work. Mm-hmm. Why it is taking so much time to do some basic thing? Yeah, that's okay. Meanwhile, we'll start our topic. Mm, but the topic is network policies. Yeah, let's see what this is about. So let's say, forget about network policy. Let's start, general. You deployed a pod. You deployed multiple pods in multiple namespaces. By default, they all can communicate each other without any issues. But of course, I couldn't show you with curl because of this shitty thing. But by default, it can be the pod can be any namespace you can able to communicate. I told you right, fully qualified domain name like your service name, your namespace dot svc dot cluster dot local. There will be like this a domain name for service where you can able to communicate with the service, which obviously the service will route the traffic to the pods, wherever you are, based on the selectors. I mean, wherever it's running in any namespace, it can be you can able to communicate. This may not be a good practice sometimes. Of course, you want them to communicate. That's okay. But what if there is a scenario that I want to restrict the communication? These scenarios will be there usually. Those kind of things will be addressed by network policies. What does it mean? Like I want to communicate, right? If I deploy something, I want to communicate. But imagine a scenario I deployed one application. I want the service to be communicated only with another service. There are hundreds of services, but I want to communicate with only one specific pod only, or specific from specific namespace only, or specific IP address only. At that time, we use these network policies. It's simply like a set of list for to allow incoming request or outgoing. Usually we call them ingress and egress. Not egress, egress, RES, egress. So ingress and egress. So this is like inbound and outbound rules. It means inbound means ingress means coming what's coming in, egress means what's going out, the traffic. So we use these network policies to restrict the communications. Depends on our use case. Now let's say I told you I want to restrict the communication from one pod to another pod, or I want to access only one pod, not any other thing. So we can able to do like that. So we simply what we do is we create a network policy and we define the label. Let's say I want to restrict the pod. That's what we discussed, like as an example. There will be a label for the pod, obviously, right? So that label will give, hey, restrict this one, don't communicate with this one, which has this label. No matter how many pods are there with that label, all will be blocked. Now let's say, hey, I want to allow only this pod. Use that label of the pod, which it's using to either to block it or allow it. Pod names we don't be using. We'll be using the label. So that's why I told you earlier. The labels are mandatory. Pod selectors, whatever we have, will be using that. Correct? Is it clear? So now, by default, there will be communication as I told you. So we just have, we with if we want to control, I mean restrict that for some security purpose, we'll be using network policy. But first, let's create a pods. I mean, we don't have pods. kubectl apply deploy. This is creating nginx pod and test namespace. This is yesterday. HTTPD. We're creating in prod namespace. Test deploy. See, get pods. Yesterday, Ubuntu pod also running. Since since yesterday they're running. I didn't check it. I didn't stop it. I guess that's okay. That's why it says unchanged. I didn't observe that. So it's running since yesterday. That's fine. It's noise. Now by default these two can communicate. Of course I couldn't able to show you because of this kernel is not. But try. It'll work for sure. There won't be an issue. Now I want to restrict them. I mean I don't want these two to communicate together. So that time what I do, I'll write a network policy. Go to here. Yes. How do I write? Simple API version. Sorry. Yeah, API version networking dot ktest dot io slash v1 kind network policy metadata. Sorry. Name test policy. Obviously. Now we define the spec. What we define here is pod selectors. Sorry. Pod selectors, how do we find? Because we deployed it. Let's open first thing. This one. Match label. See? These are the ones. App test. Same thing add right here. Pod selectors, match labels. App test. Where the Nginx is using. So here, now, okay, we are restricting it. I mean, as of now, what we did is like we just defined. So next is the condition. Okay, you wrote this match label. Okay, some deployment might be running here. What to do with this one? What we are doing here is we are trying to have, allow the traffic only from specific pod. Here this means this is the pod. Let's say test, whatever the app test pods are running. For this pod, we are allowing the communication only from the HTTP pod, whichever we are running. So let's try that. So that's one of the scenario. I mean, policy types ULI, CY, sorry, PY, PES, blah blah blah. Policy types. Ingress, incoming traffic. Egress, outgoing. And we have to define the rules for ingress and egress. Ingress. So ingress means incoming, right? So from what we are defining is like from where the request should be accepted. I mean, if I'm getting a something, the request from some pod, whether I should allow or not, this will define here. Let's say what we'll define here. Let's see the HTTPD, the label. Sorry. Uh, app HTTPD. Let's write that. Match labels, obviously. App HTTPD. Sorry. This is the. Just copy the same thing. I'm pasting here. Egress means outgoing to the same thing. Now what I did so far here is, let me divide it. Maybe it will be easy. So I am creating a network policy to this pods which has this app test label. It means whatever the Nginx we are running, right? For that pods, I'm applying a label. What I'm applying, uh, two rules I'm applying. One is ingress, incoming, and outgoing from this pod. So what I'm told is, so this pod can receive traffic from this pods which has this label, and it can send the request, the response to this pod, only to this pod now here. You observe? So this app test, whatever the pods are there, it should only will be, it will be communicated only with app HTTPD label pods, not with any other. Now what we are doing is we are restricting these just to talk to each other. Not other outside any services. Let's say we have 1,000 services, but Nginx and HTTPD, whatever the pods we have, they should only talk to each other, not other things. So now this Nginx pod will only allow the traffic from this HTTPD label pod, and it will only send the traffic also. Send and receive both. Receiving is ingress, send is egress. Sorry, I forgot this. Like this. Yeah, like this. Send is to address. To. Ingress means receiving, right? So from. Egress is sending. So to address. Remaining all are same. See. Now if you create this, what happens is this pod will, network policy will be applied to this pod where this will allow only traffic from, this HTTPD labels, and only send the traffic to this HTTPD labels. Got it? Now simply just go here, just apply it. I believe these are wrong because small I. These are fine. Yeah, let's try it. Null also wrong. Why it change all these things? Let's copy it and go here. NP network policy. Paste it. Yes. Save it. Unknown field like this spot selector. Unknown field checking the spot selector. Let's go. Okay, spec spot selector. Wait. Yes. Match labels, capital L. Okay. Policy types, ingress from spot selector. Match labels. So it should be inside. My bad. The syntax, whatever I'm writing here, should be little inside. Like this. Let's try this. It should work. It's created. kubectl get network. Wait, my keyboard M is not working. It's created. It's applied to app test, whatever the deployment we have. So now what happens is this will app test will allow traffic only from, what is the rule for us? From this pods which have this label, match labels character, and it will talk to, I mean, send the request or traffic to this, only to these labels. Got it? That's how usually we create a network policy. Anything, you can restrict anything. Like, you can try different examples, like, just now, for now, I just showed only one example. To allow only one, you can write to allow multiple things, multiple ingress, multiple port selectors, labels. So like this, you can able to write. And you want to restrict everything, simply just type, don't type anything here. Sorry, in ingress or egress, just try this. It will block everything. Of course, there is no point of blocking everything. I'm just saying, I mean, so I want you to try different scenarios here. I mean, not just scenario what I told. Multiple scenarios, like, currently what I shown, like restricting the pod only to another pod. I want you to try restricting the pod to multiple pods, or block only one pod, allow all the other pods. So like these kind of scenarios with network policy. So hope it should clear. So is it clear? We have discussed two topics. I know it's small topics. So one is jobs and cron jobs, to create jobs temporarily based on our use case, and it will be deleted once our task is done. Next thing is like network policy, which we have created. Which we have created means, like, which, in order to restrict the communication between pods, if it is required, so we'll be using network policy. By default, all are allowed. By default, all are allowed. Any namespace you can able to talk to each other. Got it?
Where we will use this in real time
We'll
scenario?
be using, like example, let's say that, you're running a database in, sorry, what is it? In Kubernetes, and the database should accept request only from one particular part, which is related to that, not any other thing. So at that time we can use this. What scenario we have is, we have multiple namespaces. I mean, different projects are using the same cluster, obviously. So they have their own things, right? They have their own databases running in each and every namespace. So each databases can talk to each other. For every application running in cluster can talk to each other. It means I can talk to another team's database. I can able to get some data, but that's not a good approach. So at the time, what they do is they'll apply network policy on the DB. So DB should accept the connections only from the pod which has this label. It means whatever the pod related to their team, not from outside teams. So at that time we use network policy. We are using that. I mean, as of that's a current scenario. Generally, I mean, everyone does that. But one of the example. Got it?
Yes.
So do practice different scenarios. I mean, except these will change, remaining will be all same. Of course, the labels also will change, but try doing it. So yeah, that's about today's class. Do practice. If any doubts, you can ask now or ping me. And one last thing before closing is, today is Friday, I guess. Yeah, Friday. Saturday, Sunday we'll have class at 7 p.m. or 7:30 p.m. if it is okay for everyone. Because morning I won't be available early in the morning these times. So Saturday, Sunday, no, just weekends. Just on weekends we'll have class at evening times. Is it okay? 7 p.m. everyone? Is it okay? Others?
Okay.
Yes. Okay.
If you're not silent, so that's yes, obviously. So tomorrow and Sunday, I mean, I think tomorrow Saturday. So we'll have class at 7 p.m. Got it? And Monday to Friday, as usual,
Uh,
7 a.m. Our timings. That won't change until I get something. So we have, maybe by next Friday or Saturday, we'll close the Kubernetes. Then we'll go to other tasks, other tools. So yeah, that's it for today. Do practice, and we'll meet tomorrow. Bye. Bye all.